Okay, so now our goal is, if you have a thin lens, we want to find out, if we keep an object at different distances from the thin lens, how the images will be formed. You understood our goal? So we want to be able to predict about the nature of the image. Will it be magnified? Will it be diminished? Will it be real? Will it be inverted? Will it be real, virtual, inverted, erect? Okay, all these things we want to find out and we want to predict just by drawing ray diagrams. So the first step is, you need to know what rays we will use to find out the image. So we call these rays as special rays. So please put your title as special rays.
Why special rays?
Because these are some special rays using which we can exactly find out the location of the image. So let me tell you how to draw them. So first draw the principal axis. Okay, once you have drawn the principal axis, do along with me, otherwise you will not follow.
1 second.
Then draw a perpendicular to the principal axis and make a lens. So this is the thin lens. So this is called thin lens. Thin lens means the thickness is so less that you can treat the center of the lens and the front tip and the back tip, okay, all to be at the same point. It's like that.
1 second. What?
These 3 points, you can treat them to be equivalent. That is the meaning of thin lens. So the thickness of the lens is negligible. Okay? Clear or not? Okay, so now every lens will have a point defined as focus, principal focus. So first principal focus, second principal focus. 2 points are defined. You need to know the difference between these two. So what comes first, object or image? Object. So first principal focus talks about the location of an object. Okay? So if you keep an object at first principal focus, so this will be F1. Please note this down, these are all very important. First principal focus. So if you keep the object at first principal focus, so let us say a point object, then the image, whenever the object is kept at this first principal focus, the property of first principal focus is that its image will form at infinity. That means you will end up getting parallel rays of light. Like this. So image is formed, see, listen. The way we define image is the point at which all the rays coming out of a single point of the object meet again at a single point. So all these rays which came out of a single point, they will never meet. Parallel rays, where do they meet? At infinity. Are you getting it? So image will be at infinity. So this is a property of first principal focus. It is that location where if a point object is placed, its image will be formed at infinity.
It is a certain.
I don't see Sparsh writing anything.
So it is a certain point
On the principal axis, at which if a point object is placed, its image will be formed at infinity.
So can you please like
So how will it be formed at infinity?
These light rays, they don't seem to meet, right? So one way of saying they never meet is saying that they will meet at infinity. It's the same thing.
Which is the principal axis?
Listen,
Total axis.
if these two rays will meet here, agreed? If I make them a little more away, they will be somewhere here. Agreed?
Oh, I get.
Now finally when they become parallel, they will meet at infinity. Which means they will never meet. It's the same thing. Clear?
So which means that there is no infinity.
What?
So the image at infinity means that the image will be formed.
Image is formed at infinity means the rays are parallel to each other.
So sir, this is a point at which when light goes through a lens, the image is formed at infinity.
Yes. Or the light rays which emerge out of the lens are all parallel to each other and to the principal axis. Okay, now let us see what is this.
So the horizontal axis is the principal axis. What is the vertical axis?
The That is not any axis, that is just the plane containing the lens. Okay, now second principal focus.
The first principal focus is the point on the principal axis,
You tell me.
from which all the rays meet at infinity.
Yes. It is a location of the object such that the image will form at infinity. Okay, now, next, let me do it about this so that you can compare. So, second principal focus will talk about what comes second, object or image?
Image.
Image. So it will talk about image. It is that position where the image is formed if object is at infinity. If object is at infinity, see, if the object is here, the rays will come out like this. Agreed? And reach the lens here. Agreed? Listen carefully now. If the object goes further away, say here, and if the same light rays, if the light rays have to reach the same point, now they come like this. Agreed?
Yes.
So what do you find? These two rays are becoming more and more like parallel to each other. So if this object goes to infinity far away, by the time the light rays come, you see here, these two are almost parallel. You see that? This ray and this ray are almost parallel. So if they go to infinity, by the time they reach the lens, they will appear to be parallel. Do you understand this concept? So if object is at infinity, we represent it by saying that the incident rays are parallel to the principal axis.
So can I draw this beneath the first image?
Yeah. So I will draw the incident rays like this. So they will all converge and meet at a single point which we call as the second principal focus.
So we can say that second principal focus is the point at which image is formed when the object is at infinity.
Excellent. Very good. You got the hang of it.
Just repeat, can you repeat? Second principal focus point is a point where the image is formed when the object is at infinity.
Very good. Write it down, please. Don't be lazy.
So you also write it down.
Aditya Gundalia.
So you also write it down, please.
Ved Madambi.
So write it now.
Wait.
The image.
Ved. Lift your pen.
Where the image
Still,
formed.
Write it.
where the object is at infinity.
You don't have a pen. Go to the lab and get it.
Sir, with this one I am writing.
Get it. Akhil. You are having a video recording. Done? Okay, now the distance of first principal focus from the lens, that is called first focal length, small f1. First focal length. And the distance of second principal focus from the lens will be called as second focal length. See, it's all intuitive. Now it so happens that for a lens, both these two focal lengths will always be equal. Is it? Will these two focal lengths be equal or different? Yes. So f is called the focal length and it is equal to f1, which is equal to f2. I mean the magnitude. Clear? Clear till now? So if this is 10 centimeter, this will also be 10 centimeter. So we say focal length of the lens is 10 centimeter. Clear? Understood this point?
Focal length is the distance between the length or between
Distance between the center of the lens, which we call as optic center,
To the focal length.
to the
Any
any focal point, or first principal focus or second principal focus. Now for a thin lens, for a converging lens like this, a converging lens is one in which parallel rays converge and meet at a point at second principal focus. So the second focal length is called as the focal length, not the first focal length.
What?
The reason is, see, actually if I add more and more you may get confused, so I am feeling a little hesitant. This is actually negative, this is positive. I'll just tell you quickly, if you don't understand, leave it, we'll move on to the next concept. Okay, I'm just telling you, if you understand, take it, otherwise leave it. All distances, okay, are measured as if you take a measuring tape, keep the zero at the optic center of the lens, and then pull it towards that point whose distance you want to measure.
Yes.
So if you pull the tape towards, along the direction of the incident ray, that length which you measured is positive. That is the definition of sign convention. So if I want to measure the second focal length, this distance, I will keep the zero of the tape here and pull it like this. Direction of incident ray is this. I am pulling the tape like this. So this second focal length will be positive or negative?
Positive.
Positive. You understood this?
Yes.
Now if I want to measure the first focal length,
Negative.
I have to start from the center of the lens and pull my tape in this direction. But this is opposite to the direction of incident ray. So this length will be
Negative.
negative. This is it. Now for a convex lens, we take second focal length, which is positive. So focal length of a convex lens is positive. But for a concave lens, it will be this side, which is negative. Okay? Now we are just going to learn about convex lens for now. Okay? So you just need to know that focal length of a convex lens. This is a convex lens. Convex lens means thicker in the middle. Convex lens means thicker in the middle.
The focal length is the distance between the center of the lens and the principal focus points,
And the second principal focus.
or the first focus.
Both will be equal in magnitude, but sign is the point. No. Second focal length is positive, and for a convex lens, focal length is positive. Okay, now that you know what is focal length, now we can define the special rays. I have to explain focal length because I needed to define special rays. Please do not fight, take me.
एक सेकंड रुक जा यार, क्या गलत है भाई? एक सेकंड रुक जा यार.
So now I am explaining the special rays, okay? To identify the special rays, you have to identify the focal lengths. So let these 2 points be at distance of one focal length from the lens on both sides. Please take notes. That's it. Draw this diagram. This diagram. This is a new diagram I have drawn.
Yes sir.
So that.
I want you to draw.
That so we are just waiting.
Draw it along with me. So this is the focal length distance. Again draw one more which is twice of this distance on both sides. So this point is 2 focal lengths away from the lens. These are 2 focal lengths away from the lens. This is the first step. Have you done this? Got it? Is this in your notebook? Okay, next.
Wait sir.
The first special ray which we will draw is, if you take a ray which passes through the optic center, it will go undeviated. So we will do it for,
So this is a convex or concave?
this is thicker or thinner in the middle. So thicker in the middle is convex.
So concave we make it in that
Yes.
for diagram we make concave also like this.
Concave should be thinner in the middle, so you will make it like this.
So the last one was concave, right?
Last one was thicker in the middle like this, so it was convex. Okay. So if a ray passes through the optic center, it will go undeviated. This is the first special ray. Aditya, switch side. Switch side, please. So if a ray passes through the optic center, it will go undeviated. That is the first special ray. Clear, everybody?
From any angle.
Yeah, from any direction. If it passes through the optic center, it will go undeviated.
What?
Undeviated, without bending. Now the second special ray is, if a ray is parallel to the principal axis, if the incident ray is parallel to the principal axis, what will it do? It will pass through the second principal focus of the convex lens. This is called second principal focus, you remember?
Yes, yes.
This is where the image will be formed if object is at infinity.
So infinity of that.
So the second special ray is, any incident ray is parallel to principal axis will pass through the second principal focus. Clear, everybody? Now the third special ray is, any ray which passes through the first principal focus, what will it do? What will it do?
It will become parallel.
It will come out parallel to the principal axis. This is the third special ray. Any incident ray which passes through the first principal focus will come out parallel to the principal axis.
So, what was the definition for 2?
Any ray which is coming parallel to the principal axis will pass through the second principal focus.
Isn't that the first principle?
Second principal focus is the location of the image when object is at infinity.
So, is your first का क्या था?
First principal focus is the location of the object when image will be at infinity.
No, first special ray.
First special ray is the ray which passes through the optic center without bending. Okay? So using these three special rays, we will try to figure out where the image will be formed in each case. So let's start.
So, what is the name of that line? The P line?
Huh?
So, what is that called? The P line?
Ray 2.
No, the line.
This is called principal axis.
So, ये मिनट
Copy it fast.
So, third की बता दो एक बार. Third one.
Any incident ray which is passing through the first principal focus will come out parallel to the principal axis.
Second is the any which is going parallel to the principal axis will go through the second principal.
Very good. Clear, Akhil? Everything is clear so far?
Yes.
Okay, Akhil, tell me, if a ray is parallel to the principal axis, how will it go? Which? Very good. Can I erase it now?
No, sir. Yes, sir.
Okay.
So no delay.
Who is saying that? Be fast. Done. See, you have to learn how to listen and write at the same time. Once you go to college, they won't give time to write separately. So you need to develop this skill. As you listen, keep writing. Use your brain more efficiently. Where Madam, please sit up.
पैर पकड़ के सो गया क्या वो लगा that was insane.
He became a statue, holding his pen and his laptop.
वो सो रहा है
नहीं वेट फिर पढ़ने के लिए पुस्तक रखिए.
Okay, enough?
फिर कहता है मुझको
Okay, now you need to see, we have to draw 6 diagrams, one below the other. So what you do is, if you have a small notebook, turn it like this, vertical. If you have a small notebook, make it like this. This is one page, this is the other page. If you have a long register, you have to use the entire one side of the page. So do it, get ready accordingly. It's it.
Yes, sir.
Turn your notebook like this.
I'll have to skip a page.
Yes, skip a page. We have those 6 diagrams in one page, then only you will see the pattern, like what is happening. You can compare the diagrams. If you do it separately in different location, you can't compare. Understood, everybody? You said,
Yes, sir. Sir, one second.
get ready, turn the page.
Ready.
Hurry up, we need to rush.
The 6 diagram.
Yes, 6 diagrams. So I will do one thing. I will erase this so that I have more space. Okay, so what you need to do is first draw 6 lines like this, equally spaced. 1, 2, 3, 4, 5.
So occupying the whole page.
Yes, utilizing the entire space from the top to the bottom of the page with 10 minutes to wait and then go ahead. It's a very difficult topic, important topic. Okay, 6 rays are done. Hurry up. 6 should be there. Sparsh. 1, 2, 3, 4. So your paper got filled up. Please select your space accordingly so that you can have 6 horizontal lines. Very good.
So, pura length should be this.
Yeah. Okay. Then what you do next is through the middle you draw a vertical line. So this is the position of the lens. So now you can draw a lens like this.
So equally spaced.
Like this.
It should be equally spaced to make a rectangle.
Like this, see how I did, like this you have to do.
So the lens should be equally spaced so they can be in middle.
Try to make it equally spaced because you need to give space to every diagram, right? You have to draw 6 ray diagrams, so you need some space for each ray diagram. So you need equal space for all, equality. Next what you do is, at some distance from the lens, draw a vertical line. This will represent the focus, first principal focus. Same distance on the other side of the lens also you draw one line. That will represent the second principal focus. So this will be f1. Again same distance to the left and right you draw f2, which is twice the focal length. Or we'll just call it f. A distance of 1 focal length, and this is a distance of 2 focal length. Okay, I'm going to do fast because of lack of time. You can refer the video for revision. Now you just try to observe and understand otherwise. Okay? If you are not able to do as fast as me, just observe and understand. Later on you can do it at home. Okay? But understand clearly what I'm doing. So I mark the position of F to F, F to F. Now I want to know how the image will be formed for 6 different positions of the object on the principal axis. So if the object is at infinity, so object at infinity, next is beyond 2f, next is, so beyond 2f means the object is somewhere here. At 2f, that means the object is at 2f. Next, what will it be? Can you guess? No, between 2f and f. So it will be here. Next, can you guess? At f, very good. Next, can you guess?
Between F and L.
Between f and s. So it will be here. So each of these cases, using any of the 2 special rays out of 3, you will draw the image. So let us do the first case. If the object is at infinity,
The rays are
When
parallel.
the rays come out, okay, they will come out parallel. Okay? So if the rays are all starting from a point above the principal axis, all the rays will be parallel to the ray which is going to meet this from that point. Okay? But it's so far away that it appears like a point object. Do you realize that? If this pen is close to your eye, it appears big. If it goes further and further and further away, it appears like a dot. So if this is also at infinity, it will appear like a dot. So by the time the rays come from the top of that object, they will all appear to be parallel to the principal axis. So if the rays are parallel to the principal axis, how will they go?
They pass F. The other way.
So they will pass through this F.
Like you can do.
So remember to draw the arrows. Very important to draw the arrows on incident rays as well as refracted rays. So what is the nature of the image? So we'll say, is it magnified or diminished? Is it real or inverted? Real or virtual? Is it erect or inverted? So in this case it is point sized. It's a real image because the rays actually meet in space, and it is going to be inverted because when you do for this case, you will find that the image is actually inverted. But as this goes back and further away, it gets, the image is smaller and smaller and smaller and appears to become a point on the principal axis. So from the inverted position, it has shrunk to point size. So it's actually inverted, magnified or diminished. M is for magnified, D is for diminished. R is for real, B is for virtual. E is for erect, I is for inverted. These are to erect. Erect means if the object is above, image is also above the principal axis, same side. If object and image are on same side, it is called erect. Okay, now in this case, we will draw a ray which is parallel to the principal axis. There is a special ray. It will pass through the focus.
So what does I mean?
I means inverted. Like now it will happen, you see. And the second special ray will take the one through the center of the lens. So you saw what happened? They intersect at this point.
They just decay.
So this is the real image. Compared to the object, it has become bigger or smaller? Smaller. So it will be diminished. Is it on the same side or opposite side of principal axis? So it is inverted. And since the light is actually meet, it is real. Clear?
So how is the first one inverted?
That's what I said. See, when the object is beyond 2f, it's an inverted image.
Was it the first one?
I am explaining that only, listen to me. It's inverted. If you move it further away, this image will come closer to the focus. Okay? And if it goes all the way infinity, this will come to focus. But throughout it has been shrinking, becoming smaller and smaller and smaller. So from inverted, it has become smaller to zero size, point size. So it's inverted. The inverted of the image only became small and became a point. So can you just hold on for 2 minutes? I'll give you these two.
So just give us a late check. Very late check.
Yeah.
ASH still got me to
Who?
MGP sir, you didn't say that.
So give a late
Okay, fine, go.
Yeah.
So sign a late chip for the
It's okay. I'll continue after this. Like this, try to finish it on your own.
आप करते रहो मीटिंग में
It's okay.